Hey everyone, how are we doing? So good to be back. We got so many people here. We got Tiffany, Kylie, Casey, Jack, Michaela, Abigail, George. Great to see you here. Let's take a look. Let me go to live chat. Tiffany's got a question to start us off right here. Dan, hey, thank you, Dan. Doing better last week. People probably like Brian, we've heard you talk about last week so much. It was super rough. Was recovering, had surgery on Monday last week, and thus everything got shifted around. Saturday, Sunday, Monday last week, I got an average of like 2-3 hours of sleep a night. I'm getting the Stat 1 loaded up in the background here as we talk. So I was sleep deprived last week, had surgery, was on painkillers. So my productivity was not there last week for good reason. But this week doing way better, way better. An investment website can tell which devices are used across their site. Their site managers wonder whether they can use and enhance the facilities for trading via smartphones. Proportion of users who access, they draw from random sampling distributions from Chapter 13. Cool. Let's take a look. Sampling distribution of sample proportion, Chapter 13 quiz. Thank you, Tiffany. Excellent work on telling me which one it is. So that way we can get it pulled up right here. And I've got it. We haven't done the nearsighted one. Thank you so much, Dan. I appreciate that. Hey, Kayla, good to see you here. Kayla, good to see you, Kayla. Always good to see you. I actually showed your work again yesterday during a faculty meeting. Almost got the assignment thing pulled up. But it was just showing the impressive work that people have been doing. And your work came up. Your work was like, hey, check it out. Impressive work. Thank you so much, Kayla. Yeah, Monday last week, I had to go in for not a huge major surgery or anything like that, but had to go in and get the surgery done, and then was on painkillers, got relief, and doing much better now. So, but not sleeping really did me a number. And then, so, yeah, but we're doing better. So we're going to hop in here to the first question from Stat 201, Chapter 13. Let's go take a look at Chapter 13, Stat 201. 100 points right here. Let's get Mubot back awake. Mubot, you awake? Oh, he says I'm not awake. Mubot, wake up there, buddy. Wake up, Mubot. Okay. You gotta get your head in the game, Mubot. Okay. So an investment website, all the stuff right here. So what's the first thing we do, Tiffany and anyone else? What is the first thing we do whenever we come across a problem? Whenever we come across a problem for Stat 1, especially for these chapters, ignore what I just clicked. That's the wrong answer. Whenever we come across a problem like this, what should we do immediately when we see a problem like this? What should we do immediately when we see? What are our steps? We reviewed this yesterday. So what are our steps when we see a problem like this? Yeah, we'll take a look at that here in a little bit. You got it, Allie. You bet. What are our steps for 201 whenever we see a problem like this? What do we do in our steps? So from yesterday right here, we're going to label it. Kylie, amazing answers right there, Kylie. Kylie, you're getting it. We're going to label everything. We're going to put that notation on here like we did yesterday. Practicing the notation is key right here to see what we have. So when we do this notation, thank you, Kylie, great answers. We're going to go right here and start marking things. A random sample of this was taken. So this is going to be the sample size. Suppose that the true proportion, I need some help right here. What does true proportion mean? What is true proportion in notation? It says, suppose the true proportion is this. So suppose the true proportion is this. So what is, in notation, true proportion? We have to practice the notation. We have to know notation like, oh, they're saying, so we're supposing the true proportion is this. They're literally telling us that this is equal to this. So they're saying, suppose it's actually that 40% of people use smartphones. God, this question's old. So what notation have they just told us right there? What notation do they tell us when they say, suppose the true proportion, they're saying, suppose the truth is this. Great job, Tiffany. Some extra points. You got it. Tiffany knows that P is equal to 0.40, and then we can find Q instantaneously, which is just the other side of it. It's the complement of it. So remember, P and Q add up to 1. Once you know P, you should know Q. Just write that down and have it ready to go. So we actually have a lot of what we need. Now, if we meet our 3 conditions right here, condition 1 being random. So condition 1 is that they randomly selected these things. Condition 2 is that these 407 customers are less than 10% of all their customers. And condition 3 is that we would have at least 10% expected successes and at least 10% expected failures. I'm doing these conditions here in the background because the question doesn't ask for it, but I would expect 162.8 customers to use a smartphone. Don't worry that it's a decimal. It's all right. And I would expect, I'm doing NP/NQ right here. So if you're wondering the mathematics I just did for the third condition, we'll show it here visually from yesterday because we're just doing a check. The third condition is the NP/NQ condition, and we solved one out yesterday using NP/NQ to solve out the expected number of successes and the expected number of failures, and both need to be greater than 10. So we have here the conditions that we just checked, kind of doing this problem in order. Now, if we meet all the conditions, what can we do with our distribution? What can we do with our distribution if we meet all the conditions? If all the conditions are met, we can say it should look what? This is the whole point of meeting the conditions. We go through, we mark our notation, then we check the conditions, and if we meet the conditions, we can say it should look whatly. That's what that stands for right there. It should look this, which is actually the answer to the first question. If we meet all three conditions, then the distribution of the sampling distribution of the sample proportion, it's a lot of words, should look what? We can draw it looking this way, which is what that stands for and the way that looks right there. The whole point of meeting all three conditions is that if we meet all three conditions, it'll look what? That's not the answer. Yeah, we can do it. Yeah, Taylor, we'll do it here. You bet, Taylor, we'll do that one. You got it. Bill, we got a few more in order, but then we'll do that referendum one. You bet. Unimodal symmetric, and that stands for normal. So I wish it just said normal right there, but unimodal symmetric is the normal curve. So that's what we're seeing right here with these visualizations down here is that we're drawing the normal curve. It's unimodal, it's symmetric. And thank you, Taylor, for swinging by. 50 points, Taylor, for asking that question. We'll be doing it here in a little bit. So unimodal symmetric. So let me ask you this, though. Here's the complex questions. We know right now, remember from this question, we know, and here we'll shrink it down here a little bit. We'll put the information we know over here on the side. So we know 40% of people have a smartphone. We know that. So if I took a sample, what would you expect to see? So here's the way it looks in notation, is that we know 40% of people have a smartphone. That's the truth right there. So if I were to take a sample, what would I expect to see in that sample? This stands for the expected value of a sample proportion. Like, what do I expect to see in a sample? Can you tell me what that solves for? What do we expect to see in a sample? If 40% of people take a smartphone and I sample a bunch of customers, what percent of those customers would I expect to have a smartphone? If 40% of customers own a smartphone and I take a sample of customers, I would expect what percent of those customers to have a smartphone? And this is not something you multiply. This just says expected value of the sample proportion is this, or the mean for the distribution of the sample proportion. It's like saying, what do you expect? Yep. Tiffany, you're doing it. Great job, Tiffany. You got it. Yeah. And so this right here is just exactly what it is. It's 40%. Because I expect 40%. If 40% of people have a smartphone and I take a sample, I'd expect to see 40%. The standard deviation of p hat, which is the variation that we see, is going to be p times q over n square root. P times q over n square roots. This is why we wrote out all of our notation, because if we have the notation, we're just going to plug in p times q over n and square root the quantity, and we've done it. So this right here is the mean. We expect 40% of the customers to have a smartphone, and then the standard deviation is p times q over n square root. And make sure to round down to 3 decimals. That's got it. And what do you think, Tiffany? How are we doing? Does that make some more sense? A lot of good practice right here. A lot of good notation. Brian's shirt is just vanishing. I like this shirt, but it's yellow. It's not green like the green screen back there. That's why it's maybe not doing it perfectly. But this has it right here. Good question going over it. We're going to hop to another question right here. I think Kylie's got the next one. Chapter 13 homework. So I guess Kylie asked if we can do a Chapter 13 homework and quiz. So we've got Kylie's question, which I'm going to wrap into the question from Taylor just asked one. So we'll do the referendum. So let's put a break in the video right here. So this is Kylie's question, but also Taylor's question, so we can do Taylor's, get that out of the way, because Kylie said, can we do one from the chapter 13? So we'll do the referendum, because that was asked later on, but also could you do one from the chapter? So let's do the school referendum. That looks accurate. I'll double check it mathematically on my side. Let's do the school referendum right here. 2 seconds, I'll check your mathematics. And 0.034. Yep. I just want to do random questions. You bet. Yeah, the school referendum one's pretty interesting. You have to use an extra assumption for it. It's good practice. School referendum one is pretty good. Okay. Latest marketing research. New restaurant. Bank. All right, here we go. School referendum one. A little tricky. Got a trick in this one. Let's go check it out. This one's tricky. Checking out school referendum. So Casey, the good thing about this, or the bad thing, these questions, what must you know? So hey, Casey, let's practice this. You ready? This question is not that difficult if you narrow down all the notation for it. So what should we do? Try to follow along with me right here. And as I go through this question, mark the notation. Now remember, if you watch me solve it, that's good. If you solve it with me, that's better. So what notation do you see in this problem immediately? Yep, your math looked good, Tiffany. Yep, great job, Tiffany. Excellent work. 100 points, Tiffany, everyone else. So what notation do you see? We should get, there's 4 bits of notation in this. And Taylor, great job, Taylor. Taylor sees the sample size right there. That's sample size. So when Taylor says N, I say that's sample size. You might say there's 4 things. Ooh, there is. There's 4 things to be found. Great job. And it's technically lowercase n. Technically lowercase n. 50 points right there. Lowercase n technically. 0.55 won't be x. 0.55 won't be x. We could solve for x, but it won't be needed for this problem. So what else? I'll give you a moment to think through. There's here's hints of where things are at. Correct, Casey. Look, Casey, you got this. That's the true proportion. It says, suppose that the budget has this support. So it's telling you the true proportion of people who will vote for the budget is this. Does that make sense? It says, suppose, no, Taylor, don't worry. Taylor, you got that right there. You were right. P is 0.55. That is the true proportion of people who will vote for the budget. So remember, P is the true proportion. So what can you get instantaneously now? Keep going. You got this. What can you get that you know the true proportion? I put Q. Great job, Taylor. You're getting it. So Q right here is the complement of the true proportion. You're doing it. And then here's the hard one. I'll do the tough one. Great job, Casey. So the tough one right here is that it would predict defeat. This is like where this question is difficult. So if we put here predicting defeat, then that means in a sample, like if the newspaper goes out and polls people, like imagine you went out and talked to 2 people and both of them said, I'm not voting for the budget. I'm going to vote against it. Then what would you predict for the budget? Like if you talk to 2 people, would you predict it's going to pass or not pass? You just talk to 2 people. I know that's only a sample size of 2, different from this problem. But you talk to 2 people and they say, I'm not voting for that. I'm going to vote against it. You vote for 2 people and both of them say they're voting against it. So what would you predict for the budget then? You say, I talked to 2 people and they said they're not voting for it. Now that would have a lot of uncertainty, but if you talk to 2 people and they said, I'm not voting for that budget, then you would predict what? You would predict the budget would what? You talk to 2 people, and from the 2 people you talk to, you'd predict the budget would what? Because they both said, I'm not voting for that budget. I'm going to vote against that budget. You would predict from that the budget would not pass, right? Now, it's a very small sample. But they will predict defeat if in their sample, they view a sample proportion less than 50%. So we're actually asking for the probability. It failed. Exactly, Taylor. Great work, Taylor. You got it. You got it. Just practice along right here. So that says a sample proportion of 50%. Great job, Kayla, right there. We got both Kayles here today. So they want to see the probability of a sample proportion less than 50%, or they're interested in if it is 50%. So now when we look at this, if we pass our conditions, if they randomly talk to people, if they talk to less than 10% of all people who are in this district, And also, we passed the success failure condition, which says we need at least 10 successes and at least 10 failures, which would be 0.55 because it's NPNQ. This is not asked by the question, but we could check it. 0.55 times sample size, that is bigger than 10. And we are just checking the success failure condition to be thorough in doing our steps of random, 10%, success failure, checking conditions. How did you find p hat again? So this is derived from this question because it says, how would we find if defeat would be predicted? So would you agree with me if they go out and they find in a poll that less than 50% of people, hey, Colin, good to see you here. Thank you so much, Colin. If they find that less than 50% of people are going to vote for this, they would predict it's going to be defeated. This is the theoretical portion. That's the hard portion to figure out for this. That if they were to poll people and they were to find out in this poll that less than 50% of people are going to vote for this, they would predict it would be defeated. Does that make sense? That's the hardest part because it doesn't say less than 50%. I think on a test we should tell you things like that. But if they were to go out and poll people and they found 48% of people are going to vote for this, they'd predict it's going to be defeated. So for it to be predicted to be defeated, the newspaper would have to find in a sample less than 50%. Does that make sense? We could put the sample proportion is less than 50%. We're interested in this right here. Yeah, that's the toughest part of this question, probably. No joke, I had an instructor ask me how to solve this one because it's got that little trick there at the end. Wouldn't love this as a test question. We would probably tell you like what's the probability of it predicting defeat, which means less than 50% of people are going to vote for it in the sample. So now from this, we are going to solve out the normally distributed model with the mean of p and the standard deviation of p times q over n square root. So go ahead and I'd like for you to take a moment and tell me what's the center of the distribution. Now, all of this stuff I just wrote right here is when we talk about the mean and the standard deviation. So what is the center of the distribution going to be? What is the center of the distribution going to be? The mean, which is the center. 0.55. Casey, great work there. Casey, I'm going to make you mod. I don't usually make people mods during office hours. Maybe you're really like, I'm going to come in here and do a bunch of questions. And nah, I trust you. So that'll go here at the very center of the curve. The mean goes at the center. I don't know. There we go. And that'll be 0.55. Now you need to calculate what? So now that we know the mean of the curve, and this says if we go out and take a sample, I'd expect 55% of people to vote for it because that's the truth. Now that doesn't mean 55% of people will vote for it in every sample. So what is the variation right here? And all we did was plug in. Here, I'll start plugging in the numbers because that's the mean. So we just plugged in 0.55 because that's literally that, which is that right there. So it's we just took from the numbers. We said, well, the mean of the curve is 0.55. This is the same thing as writing nu p hat equals p. And SD, we did the other question this way by writing this out, p times q over n square root. So these values right here of p and p times q over n square root are the standard deviation right there and how we draw the normal curve. So we need to find the standard deviation. We need to plug in p times q over n square root. I'll do my work right below it down here for it. This is going to be 0.55 times 0.44 over 448. And so there it is right there. We're just going to times this out. Times it out. That doesn't work for that one. 0.55. Got to catch those errors. That's we might have lucked out, but that's an error. I typed the wrong number. 0.55 times 0.45 divided by 448. Remember, how do we find P and Q again? Someone's probably watching right now and say, well, how did you find that 0.45? How did you find, you got 0.55, but how you get 0.55, how you get 0.45? Remind people in the chat as I just solved the arithmetic right here to get the following. So how did we get that value? 0.0235. There we go. That's just what that solves to. We are just summing it up. They're complements of each other, so they add up to 1. Great job. Amazing work. Some points in the chat. They're complements of each other. They add up to 1. So one thing you can do right here is you can start drawing out this curve. And what you'll get is it looks like this is going to be about where 50% is at. I'm just kind of doing it from what it visually looks like to me. It's going to be somewhere over here. You know what I'm going to try to do? I'm going to try to solve this one without... There's the curve. This is about what it looks like. You can't solve this one by hand, though. Who knows where we're going to go to solve this? Anyone got any ideas where, now that we have this information, we have the mean and the standard deviation, where are we going to go to solve this? And that should be about 2%. Ah, yeah, we can do it here in Tiffany in a bit. You got it. It's going to be about 2%. I'm taking my one guess. I get one guess. So... we're going to go to David M. Lane. You got it. So we're going to the David M. Lane website right here. We're going to enter in the standard deviation. We're going to enter in the mean. And I'd like to ask you this. Oh, the mean is 0.55. So, oh, and look. How similar does Brian's picture over... how similar does Brian's picture over there look to what Brian has over here on this side of the screen? How similar do these things look? And I was lucky it gave it to me. But did I kind of draw something similar-esque to what we have? Oh, I think we will. Yeah, Tiffany. Did I, if you look at where my numbers are at, and I'm just going down the standard deviations, but was I able to draw something very super-duper similar, right? So on the test, you might have to draw something out. Also, can you tell me about what the z-score is for this? Can you look at this and tell me about the z-score? That's a great test question right here. Could you? And so if you're worried about the test, here's a thing you might want to ask yourself. What is the z-score for 50%? So the z-score for 50% would be, and this is how I got an estimate of the p-value, the z-score for 50% would be p hat minus p over p times q over n square root, which is just the standard deviation. So it's literally the observation minus the mean over the standard deviation. So we could take right here and take, and you should have a guess of the z-score in your head right now. Like use the graphic to guess the z-score and then check your work by solving it. So we take here 50% minus this. Who can put a guess for 50 points in the chat? Like the z-score should be a little bit less than this. So visually look at that and be like, oh, well, z-score is going to be close to this. Who knows what the z-score is going to be close to? There's the standard deviation we calculated up above. And so there's the standard deviation. Observation minus mean over standard deviation. The z-score is going to be a little bit less than negative what? Negative this. Make sure it's negative. The z-score is going to be a little bit less than negative this, which is how I guess the p-value, because I know some stuff. You got it, Kayla. You're doing it. A little bit less than -2. And you can see it visually right here. You can see visually it's there. If you follow down your numbers, if you're wondering how I got 0.503, I went to 0.55 and I subtracted the standard deviation and went down like that. So these are just the numbers on the curve, and the David M. Lane applet will do this for you. The David M. Lane will plot those numbers going down from the mean. If you look at the mean of 0.55, and then you go down a standard deviation each time, it's just going to go down standard deviations. Behind in the... No, Kayla, you're doing great. You're answering questions excellently. This is a harder chapter. We're going to be doing the second part of it tomorrow. This is not an easy chapter. It's a very, very mathy chapter. So practicing these problems is the key to doing it. I think, let me look at the next question we have in line. The next question came from Kylie asked if we could do that. The bank loans question is next from Casey. Thank you, everyone. And then Jack has a question for 474. We'll do that next. And Abigail's wondering about 474 also. We're doing all the questions in order. Thank you, everybody. Let's hop back to the main screen. Wrong button. I clicked the wrong button. Excellent stuff. So we have the bank loan question next. It's going to be a lot of similar work right here. You ready? It's going to be very similar. Kayla, you got this. This is the good practice right here. You ready to do similar work? very similar work. Let's check out the similar work for the bank loan question. Make sure to start with your notation and then check some conditions and then solve the problem. Here we go. The way to get these problems down is to always do them in a similar way. There's different ways we can ask stuff, but usually the formula is very similar. Step 1, what do we need to do? Someone help me out with that step 1 for this problem. You should know step 1 for any of these problems. What do we like to do whenever we get to a problem from this chapter? The first thing we should do, someone put it in the chat right here, make sure you know this if you're watching at home right now. The first thing we're always going to do when we solve any of these problems is do what? Do these steps right here in this order. Usually it helps to do this, and then you've got a way of doing it to organize your brain and make sure you solve it. The very first thing we're going to do when solving any of these problems is do what? We're going to start labeling that notation, and you know what? Thank you so much right here, 100 points right there in the chat. I'm going to label this notation for you. See if you can do it. Pause the video right now if you're watching later, and see if you can label that notation. A lot of times you'll notice numbers, and that's the best way to find stuff. So it says a bank believes 13%. I wish it said a bank knows from prior history, because that sounds like the true proportion to me. That's not from a sample. That is a truth. Now, we would have the complement of it, which is the other side. It's the 1 minus. So if you're wondering how I got that, all you do is go 1 minus this, and you obtain the Q, which is the complement of the true proportion. So P is the true proportion, like 13% of people pay their loans, will not pay their loan back on time. 87% of people will pay their loan back on time, and this is what a bank believes is true. Last but not least, down here we have the sample size, which is just how many people we are talking to in our bank. Now, we need to see if we pass the conditions. Next step right now, after labeling the notation, let's write that down for you all to see. Step 1, label your notation. We have now done this. We have labeled all the notation. Great job, Kayla, right there. Another points in the chat. Step 2 is check those conditions. Now, when you check conditions, you should always remember random. Random's going to be the first one. We randomly sample. Next one's going to be 10%, which means we sample less than 10%. I assume that these 100 customers are less than 10% of all the bank's customers. And the last condition right here, well, first, pause. I say we pause because people oftentimes just go to the last condition without thinking what kind of data we're working with. Since this is categorical data, it'll be the success failure condition. If you're looking for more in-depth talks on these, please watch lecture where I go over more in depth and we do examples and explain how these conditions are passed or failed. The success failure condition says that we need at least 10 successes and at least 10 failure. Can anyone show me the mathematics for the success condition right here? I'll write it out while you think it over. NP and NQ both need to be greater than or equal to 10. So can anyone solve for me the NP and NQ as I write out the other conditions? Customers, can you explain the difference between the sample size? Yeah, so the 10% condition, our sample size needs to be less than 10% of the population size. So this is what you must consider for the 10% condition right here. And so here we'll go over each one of these. So what was our sample size? Our sample size N right here needs to be less than 10% of the population. So Kylie, does this make sense to say the 100 customers we took as a sample is less than 10% of all customers who come to our bank? So think about our bank. We probably are like Regions or someone, or probably a big bank. Would you say that 100 customers is less than 10% of all of our customers? If that is true, you meet the 10% condition. So you have to ask yourself, so let's write some notes right here. What is my sample size? So you have to ask yourself, what is my sample size? What is the population size? So this is like all people things. All people are things. All people. This is your size of your N, how many things you spoke to. And then is the sample size less than 10% of the population size? Does this make sense right here? Like, this is the most thorough way to do it. And I'd say I took a sample of 100. We probably have like hundreds of thousands, if not millions of customers. So the 100 customers I took from is less than 10% of my population. That's exactly, you can think about it that way, Kayla, if that makes sense. So does it make sense why we pass this right here? Instances where you would not pass it would be things like we spoke to 20,000 UT students. So why, if I speak to 20,000 UT students, would I not pass the 10% condition? What was your sample size? And then what is the size of the population? So there's going to be an instance where we don't pass it, like we speak to 20,000 UT students. If we speak to 20,000 UT students, you would say, well, 20,000 UT students, the population of UT students is something like 30,000. 20,000 UT students is way more than 10% of all UT students. So you must ask yourself, how many did we speak to? What is the population size? And is what we spoke to less than 10% of the population size? This is the most thorough way to do it right here. Exactly, because we don't have 20,000 would be more than 10% of all UT students because we don't have like 200,000 UT students. The success failure condition, what's going to help us out? Do you see right here when you do the success failure condition, it's very mathematical. Can you solve, and this hopefully will distinguish, this one right here is doing the formula NP, NQ. So what is one of the numbers I need to check right here? So what is one of these calculations right here? So I need to solve NP and I need to solve NQ and need to see if NP and NQ are both greater than or equal to 10. So solve one of these right here to check. So literally, we could put some steps right here for people. Solve for NP and see if it is greater than or equal to 10. Solve for NQ and see if it is greater than or equal to 10. So exactly. Yep. Technically, lowercase n. Technically, don't worry. We won't grade on that on the test, obviously. But technically, lowercase n, because uppercase n is population size. Also, we use that for normal curve too. But capital N is population size. Lowercase n is sample size, just in notation. So technically. But don't worry. I'm at 300 points right there. We don't usually talk about population size a lot of times. So you don't see that notation much. So I wouldn't expect you to know it. And Kayla put the work in the chat. If you can see right there, NP, if you're wondering how that was found right there, Kayla's plugging in a sample size of 100 with a true proportion, which I think is capital P. So Brian's making some errors right here. A 0.13 that was found in our previous part of the problem. N is sample right there. And we times this and we get 87. So this is 87 and this is 13. And we pass because both are greater than or equal to 10. So good checks right here. And with reasonable assumptions, I would say with reasonable assumptions, we pass all of this. And now that we pass everything right here, oh, Kylie did it. Kylie, great work. 100 points, Kylie, right there. Thank you. I saw Kylie right there. Shout out to Kylie right there. With reasonable assumptions, I'd say we pass the conditions. We will tell you that it's random. Now that we pass the conditions, we can say that the curve will look normally distributed with a mean of this and a standard deviation of this. Now, knowing the formulas here is going to be key. We must know the formulas. We'll be given them on the test, but it helps to know them. The first formula is mu p hat, which is the expected mean of a sample proportion. What we expect to see is equal to p. It's as easy as it sounds. The second formula is the standard deviation of p hat, which is the variation in a sample we would take, is going to be equal to the square root, or p times q over n square root. Full square root, not just over n square root. P times q over n square root whole thing. I've seen people not square root the whole thing. So can anyone just tell me what the first formula is? You can see right there with my zooming out. Do we need a note card for this test? Not a note card. You'll get a formula sheet, so you can print off the formula sheet, which is on the Stat1 homepage. So on the Stat1 homepage, I'm also going to update this page later because it doesn't have the videos on it. But review 2 right here has the review for exam 2. I'll be doing some updates probably later today to it, adding the videos to it. Mubot, tell us where that review page is at. Mubot, you there, Mubot? So what is, I'm going to say a lot. What is P? Well, the true proportion is what we expect to see in a sample. So if we went out and gave loans to people, we'd expect 13% to not pay them back. So right here, now we plug in the other values. Good enough plugging that. 0.13, 0.87, 100. We just plug in values and we solve through. So the true proportion is that, which is 0.13. And we showed it on the previous screen, but it's 0.13 p times q over n square root. Now, where do you think I'm going to go that I can draw this out now? Now that I can draw this out and it rounds up, where do you think I'm going to go? if I have a mean and a standard deviation and things are normally distributed, I'm going to go over here to the Mr. David M. Lane applet. And so let's go right here to the David M. Lane applet. And let's go ahead and put in our mean of 13%. There's the mean. Let's put in our standard deviation that we found. And then we want to ask, great job, Kayla, right there. We want to ask, what is the probability that over 15%? Now, I'm going to ask this in an interesting way. The z-score for 15% is a little bit less than what? The z-score for 15% is a little bit less than what? It's closer to like 0.6, actually. It's closer to like 0.6. The z-score is how many standard deviations it is away. Yeah, it's a little bit less than 1, right? It's going to be in there. And so if we go to, we want to know the probability that more than, I think, what is the probability that over 15% of people don't pay loans back on time? So we want to go above 15%. So I've got a guesstimate of that. 3 decimals, that's a tough one. Oh, we didn't get it. Oh, that's our last, if we get it wrong now, we get it wrong. 27.6%. I was close. 27.6. I wanted to get it. I got it one earlier. I guess I got unlimited attempts. But it was around 26. I know where 25% is on the curve. It's set a z-score of, my gosh, my brain's breaking, 0.673? I think it's 0.673 is the z-score. So I looked and I saw the z-score was kind of close to that. But all we're doing right here is using the mean, using the standard deviation, and saying what is the probability of above 15%. Does that make sense, Kayla? Hopefully I didn't do this last part too quickly. But we know the mean of the curve, we know the standard deviation of the curve, and then we're saying what's the probability of something appearing above here. So we're saying what's the probability of a sample that we take having more than 15% of people not paying their loans back on time. So it's the shaded portion of the curve showing the observations that would be 15% or above. So anytime we land over here on the curve would be something of interest to us that more than 15% of people did not make their loan payments on time. How we're doing on this, the last part of here would require the David M. Lane, but this could be solved by hand, by drawing it. You wouldn't get an exact probability. We did the last one by drawing it out. I'm just kind of speeding it up because I want to do some more questions here. But you could draw it out and get an estimate. So this is the previous problem we just did, but check it out where we drew it out. We could have just done the same thing here by drawing it, and then we would plot on the curve right in here. So you could draw it, but a lot of times nowadays we don't have you drawing. We might show you pictures and stuff because on written tests, when we do written tests, we might have you draw it. We might say draw a picture of it to show the sampling distribution and the probability. And then we just don't have you sign the p-value because if you could draw it, you could put it into an applet probably. That's got it. Let's head back to the main screen. We're going to do a little 474 now. Great work, everybody. Hangout 201. I think we'll be doing some more 201 here in just a moment. So, no problem, there's music. Let's take a look here. The question was 474. Asked a question about JCast. Can we do the question 1D? And people are saying 1C also. Nested for loop with if statement. Okay, let's take a look at that. Let's go take a look at some 1C and 1D. Okay. Here we go, 1C and 1D for 474. Let's check it out. Here we go. So we're going to fit some models here like we did from 320. So if you're 320, check it out. Recall the syntax for predictive modeling is a variable named y from all the variables in the data set. Named data, and we have here lm, y tilde x, comma, data equal. Indicator variable in number 4. I think we can get to that, Michaela. I think we can. We'll try to, might do it right after this too. So we'll focus on the 474 real quick. So it's using predictive modeling. We need to go through and do a little pre-work on this because we need to get only certain predictors. So we got the product launch data set. We only want x1 through x20. And we're calling that PL. And unless I'm going crazy. And we want here 1 through 21. And are we doing 1 through 21? Oh, so maybe it is just that. Yeah, it is that. Haha. Okay. Run a summary to verify that there are 3 columns in profit. Okay. So this is important right here. This code right here is very, very important because what you're doing with this code is you're actually taking a what of your data. So what are you doing with this code right here, which is very important? Oh, Ali, if you had a question, sorry, I missed it. This right here is only taking what's for your data. Very important code. Yeah, I think we should have enough time. We'll try to. I might not. I'll do this one. This one's a very tough one. I might do parts. I think we got 3, 4, 5 on the board right now. So we're only taking what right here. We're only taking what right here. So what's the importance of prod launch? And then what does this mean right here? And then what does this mean? Like I'm spacing this out because this is the what space right now and this is the what space. So inside of prod launch, if you're wondering, we just could look at it this way. So don't worry about the summary. So right here, this is all the what's. Exactly right there, Kayla sees it. This is, or Michaela, sorry. This is all the rows, and we're taking only columns this through this. Columns 1 through 5, columns 1, 5, 16. Carter, great job. Carter, excellent work. So good to see you here, Carter. We're taking all of this right here, and we can make it look a little bit nicer. You can put the spaces in. It reads through spaces. Split the data into 50%, 50%. Well, messages right there. So with splitting the data right here, we need to go 50% training, 50% holdout, and we're setting the seed to get the randomness the same. I do suggest going right here. I think we're using the RNG kind, sample kind. I believe we're using a rejection. We'll double check. So now to do this, we're going to go here to train rows. I've already got some train rows. Yours probably won't autocomplete. Later on, I made some train rows. Be very careful. You can double up on what you call things. We are going to sample 1 through the number of rows of prod launch. And what this does is it's just a vector of the number of rows. Second argument is how much we want to sample. We're going to go and sample the size, the number of rows in prod launch, times 50%. And that should do it. So that'll take a random sample of the train rows right there. Now we want to create a train right here. The train is going to be from prod launch. And we're going to take from it train rows. And we're going to take all the columns in it. And then we're just going to go right here and go to holdout. And it'll be not the train rows. And now let's go here to a summary. And yep. And summary of holdout. We're good to go. Okay. For this problem, we'll revisit how we made models. So we're down here at this now. And so here's the important thing. This is where there's issues. And this is where writing the code can be a huge help. And I'll probably do part of this. So if you look right here, we have y tilde x comma data equal, which will take all the y's. But let's say, and this is the hints for this, let's say we want to make a model where we only take the following. We want to predict profit. That's the y variable of interest. Now, what will this do? Let's go to the train. We got to use the train. What will this do? Who knows what this will do right here? What will this do? What will this do? It might help if I look at it. What did this do? Exactly, Michaela. Great answers, Michaela. It's going to do profit with all the x variables. That's profit, all x variables. But what? No, I'm going to make an error on purpose. But don't wait. What will? This is a purposeful error. What will this do? Now, be careful. This is a purposeful error. What will this do? This will create a model predicting profit from all the other variables, taking the training data and only using columns 4 and 15. That's a problem, though, because where is profit? Where is profit? Profit is currently located where in this whole data set? Only part of the data frame, exactly. So where is profit in the prod launch data set? So I probably need to take that. Profit is located in the what right now? Because I'm saying only use from the training data columns 4 and 15. Profit's located where? In column 1. So we probably need column 1. But if I want to create using X4, X4 is in column what now? And I'm explaining why I'm choosing certain numbers right here. X4 is located in column what? Because you'll see profit's the first, and then we have X1, then all the X's are going to be shifted over a little bit. So X4 is located where now? X4 is actually located in column 5, exactly. And X15 is located in column 16. They're all just shifted over one because profit's in the first. And take a look. We do get the output, the same output right here. Kayla, love it. Love it. Exactly. So that's why we're choosing certain columns right here. So everyone learn a code. Great skill sets right here. So we're just shifting it over one because it's like, okay, wait, profit's in the first column. X1 is in the second column. And then we're doing this right here. And we get the same output. So we're good on this. So we should be good on that. Now we go right here, and I think this is where we make the loop. Is this where I make the loop? It is where I make the loop. So this is where, so that will work. That will work. But I want you to think about this. With that, that will work. But the way I've done it right here is so what if right here? What if I go down to here and we run, this just creates a matrix to store our values, more on that in a moment. What if I go right here and I say I equal to 5, j equal to 16, and I go and I do this. So now, what does it look like I have, Michaela, if I all of a sudden can run things like this? What does it look like I'm using if I can do things like this? If you notice what I'm doing, what does it look like I've done right here with the following? By coding it this way, be very careful with it, be careful, I'm putting it this way so it doesn't go down further on the screen. By coding it this way, yep, and do you see it? Do you see it? Do you see him? And what have we created? What are we trying to create by doing this? By doing this right here, and be very careful, do not insert things like this. Could wreck your code. I'm putting it there so the screen doesn't go further down. By doing this right here, you'll notice we actually have started the creation of a skeleton, because now we have placeholders, we have things that can change, and we can run through this. So I'm trying to think how much I want to do on this, because we need to do a few more. But this is the basics of it. But there's instances where we have an if. The ifs are going to come into play right here. Well, first off, let's do this real quick. I think this will help out enough. I don't want to write the full for loop. I'll be very careful. I'm doing a lot of practice work up here and showing how it's done. LM Profit, do you see the error? Let me see. I'll grab your code right here, Kayla. Thank you, Kayla. No, that works. No, it works. That's got it. That is correct, Kayla. Is it running? You might need to send it to me. It looks correct. It's running. I ran your model and it created. And then so that'll just create the model. And then we can look at the model and see what's in it and see what it created as estimates for coefficients and talk about it. Not me again. So now we have a weird instance, and I think it'll break if I do this. Let's find out. Let's run this. What's it going to do? Now, this is a bit of an issue. Does it turn out the same way? I'm wondering if we could just, like, not do it. 0.4008. You see, I don't even know if it has to do that. Because, I mean, I just feel like it would come out with the right answer. And then if J's also 1. Oh, what am I doing? We don't want that to be 1. That's ridiculous. Because that's profit. I was like, what looks weird there? Let me see. I feel like I'm getting a slightly different answer. 0.5478. That's far off from that. Is it seriously rounding right now? No. We'll see right here in a second. Let me try this. I've done this one a lot of times. Error in data frame, undefined column selected. This is what I'm getting, but it's so weird because that's what I'm running. Yeah. That was literally going to be my next suggestion, Michaela. That was literally going to be my next suggestion. I was like, whoa, restart R. It just works sometimes. That's the way it goes. Okay. It's my chill music. So what we want to calculate is we want to calculate how bad this model does. To calculate how bad this model does, we need to take and make predictions using this model. So we want to make predictions. We want to take predict right here. Oh, we're doing it on the holdout. I'm a fool. I'm a fool. Okay, so we want to take this model, make predictions on the holdout. That's probably why. Yeah, okay. My brain's working again now. Okay. We'll go around here and do this. Okay. Brain turned off for a second. So this makes predictions using our model. This makes predictions on the holdout using our model. So those are the predictions. So these right here are predictions. And 201, Kayla, this is actually a question for you. Kayla, I want you to tell me if I store here the actual value of the holdout. So Kayla, I want you to think about this. Here's the actual values. And I want you to tell me what are we finding by doing actual minus predictions. So the actual minus the predictions right here is going to find the what? 201, 100 points on the table. Anyone can answer this, but even 201 should know. If we do the actual minus the predicted, think of what goes before that. Oh, yeah, we did smoking seeds. Yeah, Casey, I think we got enough time. So if we do the actual minus predicted right here, what are we finding? This is 201, 320, 474. Not the y-intercept, not the y-intercept. Think the actual minus predicted. So the actual minus the predicted equals to the what? You are, so we're on the right track for those. It's the error. We'll use it to find the RMSE because that's the E in the RMSE. There's actually a residual right here. We'll use it. Does that make sense right there? Carter, great job. It's a residual where, so 100 points right there. Amazing work. It is an error term. It's a type of error. It's how much we miss by. So what we're going to do right here, and people were just saying right here, so we could call this an error. So if residual and error are the same thing, I'm just doing redundant things, actually. It needs to go the other way. I'm just overwriting it, calling it error right here. So what if we take the error, and why would we square it? We'd square it because some are negative and some are positive, so let's square the error. Then let's take the mean of the error, and then let's take the square root because we don't want squared values. So there's the root mean squared error. And if you look at this number I just found one of the numbers in the matrices confirming it's correct. This is when you use x1 and x2 to make a model right here. So we just found the number right there in the matrix. When we use x1, remember it's in the second, and x2, which is in the third. So what if I go right here and run my code? This is using x1 and x3, and we should obtain this value right here. So let's see if we obtain that value right there, and we do. So hopefully this is making sense. But now I think if we do this, this is using x1 and x1. Now you think we'd get this value, but I think we're going to get an error. Now there was an error somewhere back here. It says invalid. That's bad. So it's almost like we need a statement right here. If I and j are equal to each other, I don't want to do the full thing, but if I and j are equal to each other, we should run the code differently. So here's how we're going to run it right here. But if I and j are equal to each other, we should run the code like this. Does that make sense? Who's following me? Like, if I and j are the same value, we will run the code like this. Does that make sense? Like, if I and j, you could do it if I and j are different, run the code like this. Or you could do if I and j are the same value, do this, else do this. I don't want to quite write it out, but there's a lot on the screen to help out right here. And we need to store this value into the matrix. So you'll store that value into the ijth position. But there's a lot of help for this problem right now. But if they were the same value, you would just use this. So let's try our code right now with it being the same value. And what do we get? We get the value right there. Does that make sense? If they're the same value, we're not going to use I comma j. We're just going to take I. Exactly. hopefully it's making sense. Kayla, you got this right here. So 201, right? Kayla, 100 points. Thank you for following along right here. And so this would just be an if. Like, we'd go right here and go, I like doing this one first. So we'd go right here and we'd go if I equals to j. That's a check to see if they're the same. Then we're going to go right here and run the following code. Else we'd run the following code. And we should actually, with this written this way, is this pretty? I don't know. It's maybe pretty. Let's re-indent line to see if it makes it look more pretty. That's better right there. So if I and j are the same, run this code, else run this code. It's mad about something. It's really mad about something. What's it mad at? It's getting mad down here. What are you mad about? Unexpected. Who sees it? Because I don't currently see it. What? Else uses a... Am I wrong about the else? My brain breaking? Else runs code. So maybe wait. I thought else used... Is my brain not working? Else runs code, so it should be that. Else runs code. If you're running code, yeah, I think that's it. Else isn't a function. Else runs code. If is a function that runs code. Else runs code. Does that make sense? That's why I was mad. I used the wrong. Else is not a function. Else runs code. Functions use parentheses. If is a function that runs code. Else runs code. So just an error right there. Now my code will work. I'm probably going to stop right here, but if you were to take these values and store them, you basically have everything. How are we doing on this, Michaela? Is it looking a lot better? You want to do this in steps. You don't want to just write the whole thing. The whole point of this is not to copy down everything I write. It's to go through here theoretically and go through each step to understand how to get each component. Because if you just write down all the code, it's like, well, I'm just copy pasting. I don't even know what a residual is. I don't know why I'm changing this to conditional statements. You have to go through steps in this. There has to be a step-by-step like formulaic approach to why are we solving this? What are we getting? What's the point of this? And I think sometimes people just maybe go to the end right here and they're just like, okay, that's the code I need to write down. So if you've been following along right here, remainder steps would be store the RMSE into the matrix. I think that's basically it. Oh, and then set up the for loop for... That should be... Oh, yeah, Michaela maybe messaged me and stuff. These are the remaining steps right here. So I haven't done these remaining steps. I think we got time. So these are the remaining steps right here of store the RMSE into the matrix. That's not so bad. Then set up the loop to go through 1 through 20 for each I through j. So you need to make it a nested loop right now. So, just going here and going for, and then going another nesting on it. Where's my autocomplete? There we go. And then you just want to put in your I and your j and this right here. So you want to set that up, make the loop go through it, and now all we need to do is store it. It should work. It should work. Everything seems theoretically correct right here, but we're writing the skeleton right now. Remember, we're going to write the skeleton. We're going to make the skeleton work on placeholders, and then the skeleton, if it works on placeholders, should work if we have it change the code throughout. So remember, you never just write all your code at once. You don't start by writing the for loop. You get your skeleton working. Once you get your skeleton working, you take that skeleton and you just plop it in there and you say, okay, we're good to go. But we still don't have the aspect of storing the value as we go through here. So let me know if you're stuck on this. Pretty tough question. I think we have time for just a little bit more here. We'll go back to the main screen. Let's do another question. Gonna listen to some 80s music. Need to download more music from YouTube. Okay, so another question was, we'll do one more 474 here. 474, I need you to vote. 474, I need you to vote. Question 3, question 4, question 5. It is your vote right now. We got just enough time to do at least one more. But take a vote right now, 474 or 201. You can, I don't know. Let's do some question. So this is 474. It's question 3, 4, 5. Which one shall we do? Vote now. We'll let it go for just a few seconds right here. Maybe like question 2. You didn't tell about question 2 yet. Take a vote in the chat. We will do. Oh, it's a 50-50 split. I have to flip a coin. Got my random number generator over here on the side. Question 4 is winning. How did question 4 all of a sudden start winning? Win the vote right here in 5 seconds. 5, 4, 3, 2, 1. And that's the end of the vote. Let's end the vote right here. I think it's going to be question number 4. Let's see. Can my question be first since we do in late office hours? Yeah. Definitely, Tiffany. You bet. We'll be doing afternoon office hours today. We are back. Back doing more office hours. Question 4 went with a lot of votes there. So question number 4 is going to be the question we're going to check out right here. Let's go check out question number 4. Now I'm going to point out something to start. I have broken my RMD file. Let's go take a look at this. This is question number 4 for 474. Please note, Brian has broken his RMD file. You'll see right here that everything is messed up. This is very bad, and you don't want to do that. So the reason being is the hashtag right here that I made earlier. If you see stuff like this, you've caused a problem, and it was this that I created. So now the problem is fixed. Please note once again that you can see problems like this appearing, and sometimes I do this. How to explain indicators? Yeah, well, I think we have just in time. We'll do that too, Michaela. So question number 4 right here. Consider the value data using the LM function not train. Fit a multiple regression model predicting customer lifetime value, a customer's lifetime value, yada, yada. Using all predictors, no interactions on the entire data set, print to the screen the summary fitting a model. So we are going to use consider the value data, exactly. So we're going to make a model right here. And we're going to predict customer lifetime value, ~, and data equal. Do we have it loaded in? Value. There it is right there. And let's close it and let's run it. Oh my gosh. There we go. You play in the back. Thank you so much, Michaela, right there. When is this office hours over? I think it's over right now, technically, but yeah, just doing a little extra work right here. Nearsighted, we might have enough time. We might do the nearsighted. We'll definitely do it later today, Andrew, if we don't do it right now. I think technically it's over right now, but we hang out a little bit longer. My next class is at 12:10. So I try to take a little bit of time between classes. Summary of this model right here. Okay. So I'm not going to answer all these directly. I want you to kind of listen to some of these. And let's talk about these right here. And I think here's the biggest thing. Let me go look at the notes. So a big thing I want to point out right here is I'm pretty sure we have an interpretation thing. So I want to point to this. This is huge. Model. Where's model? So pulling this up. I thought we put an interpretation thing on here. And let's go back here. So this is a review question from 320. Go over that more next class. Okay. Yeah, so interpretation is key right here. Let's write this down. This is big for 320 also. I want to put this in the video for 320. Okay. So when we do interpretations right here, so interpretations, good to see you here, Peyton, right here. So interpretations of coefficients. 474 doesn't focus a lot on this because 474 is more predictive modeling. I take some breaks here and there. 474 is more on predictive modeling, and this is more descriptive. So this is also good for 201. I'd give you credit on the test. Please tell me if you don't get credit for things like this. This is descriptive modeling right here. So please know this. This is how we interpret coefficients. 320, very important too. So I need to label this for 320 and 474. We have two observations that are otherwise identical but differ in X by 1 unit are expected to differ in Y by B sub I units, where the observation with the higher X is expected, not will, expected to have a higher / lower Y. Okay. Two observations. That needs context. Otherwise identical, but differ in X by 1 unit. That needs context. Oh my gosh. Wrong button. Differ in Y. Needs context. B1 units needs context. The higher X, whatever X is, needs context. And this needs to be selected. Okay. There's a lot going on right here. And this is for quantitative. This is for quantitative. Quantitative X's in multiple regression. So the multiple regression part is only the what component of this. What do we add in for multiple regression? So when you're doing a multiple regression, what must you acknowledge about your model? So it's a good review for 320. So if you're here for 320, we highlight this and we talk about you need to acknowledge this in multiple regression. That you have two observations. You're going to talk about how they differ in X by 1 value. So you would need to then do what right here? This is for only quantitative X's. We'll talk about categorical here in a moment, which answers both parts of this question. So what part of this is the acknowledgement of a multiple regression right here? What part of this is the acknowledgement of a multiple regression? In what part are we being like, this is multiple regression? What part of this is like, we're doing multiple regression right here. You should take note of that. What part of this whole thing right here is the whole multiple regression? Who knows? There's a very important statement. Otherwise identical, Michaela, you got it right there. Great work, Michaela. The otherwise identical component is the multiple regression saying all other X's are identical. If you remove this out right here and you just do quantitative X's, this would be two observations that differ in X by 1 unit. So this is now simple regression. So does that make sense, Peyton? Everything right there? This is now simple regression. So this is simple regression, which is 1X. So if you look at the change right here, by going to multiple regression, we have to do an acknowledgement that they're otherwise identical in the other values of X's. So two observations that are otherwise identical, like everything about them is the same, but they differ in X by 1, like whatever X we're talking about right here, are expected to differ in Y by B1 units, where the observation with the higher X is expected to have a higher lower Y. How will we decide between the higher and lower right here? How would we decide if it's going to be higher or lower? When we talk about this X right here, which like here's an X for like wallet share, which I think is a quantitative. Wallet share is a quantitative value, or total transactions, like the total transactions people have. How will we decide if it's higher or lower? Total transactions is one of them. I'll do wallet share. So we'll put this down to the bottom of the screen. How will we decide the whole higher or lower thing? Trying to get it on the screen one time. So we're going to talk about the wallet share. Exactly, Michaela. Yep. So two observations that are otherwise identical but differ. So two individuals. We'd probably want to say two individuals. It's not always individuals, but these are people. Two individuals that are otherwise identical but differ in their wallet share by $1 or percent, whatever wallet share is. Sorry, I don't know what wallet share is. The other ones tell you up here. Wherever that, it's up in the parts of the problem. But two individuals who differ, two individuals that are otherwise identical but differ in their wallet share by 1 unit of wallet share, I'm going to say that, are expected to differ in their what? What is the Y value? Customer lifetime value by, and now we're going to go to the coefficient right here, which is B sub I. That's just meaning for the ith coefficient, whichever one we're talking about, by 6.7521, where the observation or individual with the higher wallet share is expected to have a higher lifetime value. Does this make sense? I'm going to repeat the in context again. It's important to give the context. So two individuals that are otherwise identical but differ in their wallet share by 1 unit of wallet share are expected to differ in their customer lifetime value by 6.7521, where the observation individual, with the higher wallet share is expected to have a higher customer lifetime value. Oh, you're welcome, Carter. Glad this is helping out right here. This is also some 320 review. So now we get into where we do categorical X's. So categorical X's, I'm glad to be back, everyone. Glad we can do some work right here and practice this. So now there's a change right here for categorical X's. Categorical X's is when you might say, well, wait a minute, I thought QQ straight enough, no outliers. Yes, we can do that by turning categoricals into what? Michaela knows the answer to this. By turning categoricals into zeros and ones, we create this type of variable, which turns categoricals into, you might say, but what? You can do that? You can. They're called indicator variables. I think Michaela's going to put in the chat here in a second. They're called indicator variables, and indicator variables are when you turn categoricals into zeros and ones. So now we got to be careful right here. It's going to change a little bit. Two observations that are otherwise identical, but let's go right here. But 1x is the reference level, and the other is the indicator level. The one that is the indicator is expected to be b sub I higher / lower than the reference. Okay. So exactly indicators right there, and let's highlight all this. But 1x, or one individual, but one, yeah, we can do that. But one is the reference level. It's 320, we'll begin to this. And the other is the indicator level. But one is the one that is the indicator is expected to be b sub I, whatever that is, higher / lower than the reference. So this becomes a big fill in the blank right here in understanding what we have to do. So when you look at things like, I like this one right here, married single. Now, married single, this is the value days, all right? What are, oh, not levels. There we go. What are the two levels to married? There's married, and married single. So you might say, well, what is married single? This is telling you the name of the variable, and then this is telling you the indicator variable inside of that variable. So there's not a person who's married single. There's a person for the variable married who has the value single. Does that make sense? There's not a person with gender male. There is the variable gender with the indicator level male. Does that make sense right there? That the variable is not gender male. The variable is gender and the level is male. And married is the reference. And if you remember from 320, the reference is first. I am first, logistic last. If we were to do some logistic, we'd talk about that here, but we're not doing logistic right now. And this is for, this is only for quantitative models we're working with right now. So great job, Michaela, 100 points. Excellent work, Michaela. So married, because it comes first, is the reference level, which we will compare things to. So if we were to do comparisons right here, let's talk about that. So married single is the indicator variable. It's indicating the coefficient right here of how this impacts people if they're single. And so once again, the variable right here is just single, or excuse me, the level is just single inside of the variable married. So if we're asking people, are you married, with answered married, single, two options. And these are the people who are single. Very confusing right there. So two individuals that are otherwise identical, like everything else about them is the same, but one individual is what? Married, and the other individual is single. The individual that is married is expected to have a lifetime value that is negative 17.0395 lower than the person who is married, because we're comparing them to the married individuals. Is this making sense right here, Michaela? You can always tell what the reference level is by finding what level was not included. Like if you're looking at other variables and you're like, well, what is the reference level for like another variable? You could take a look at certain things, and it's always the first one, but you could look at your output and the reference level will not be included. So if you look at these, you can be like, well, what is the reference level? Well, if you look at all the levels, the one that's not included is the reference. The reference does not get a coefficient. So that's why this one right here has two levels and thus creates one indicator. There's a lot more to income. You notice 1, 2, 3, 4, 5, And you notice 1, 2, 3, 4, 5, 6 with the first alphabetical not being included, which is the one we will compare all of these to. How are we doing, Michaela? This is a very good review of 320. Interpretations right here, a little more fill in the blanky, which we like. Just kind of understanding how to handle this right here. Tommy Pickles right here. Do you have a blanky? But hopefully this helps with understanding how to do these interpretations. 320 should also look at this. This is a huge thing for 320. I'll try to like tell them, I'll be teaching them here a little bit. I'll be like, hey, at the end of office hours today, I did some major interpretation stuff for interpreting multiple regressions, made it fill in the blank. I might even just show this right here in class. But there's the quantitative X's in a multiple regression, and then there is the categorical X's in a multiple regression. So let's put right here a note, only for quantitative Y's. So this is only for quantitative Y's. Yeah, exactly. We would, and then just lower than the reference. Exactly. If it's negative, then we would expect, like the one we just did was like with married or something like that. So I'm just kind of making up the numbers as I go right here. 2 individuals that are otherwise identical, but one is married and the other is single. The individual that is single, because that's the indicator variable right here. The individual that is single, that's the indicator right here, is expected to have a customer lifetime value that is 17.0395 lower than the married person. See right there, lower than the reference. You just need to make sure you know what the indicator is in the reference. So, you know, if you think about how you would just communicate this to your boss, you would just say, we expect people who are single to have a lower lifetime value. We generally see that. Like, this is very wordy. It's very super accurate and very mathematically correct. But yeah, exactly. Great job, Michaela, right there. So when you think about it and what we're doing, we're just saying, generally we say among people who share the same qualities that the people who we work with who are single have a lower lifetime value. It's a difference of about 17 in the value. So if we're going for customers, not saying we will get more from the people who are married, but we kind of expect to have higher lifetime values from married customers. Does that make sense? Like, this is me talking in a meeting without throwing around numbers too much and saying very mathy. But once again, let me say how I would interpret this at a meeting if I was talking to bosses. I would say, well, you know, we made a model to try to understand how much our customers are worth. And when we look at the married versus the single people, we're generally seeing this gap of about -17, which kind of impacts the single people, where the married people generally have a higher lifetime value. If people are generally the same, like they're the same distance away, they have these other qualities the same, we would expect for single people to have a lower lifetime value of about 17. And this is going to impact our profit right here. That's how we would talk about it at a board meeting. We would say, like, we see a difference of about 17 between our customers who are virtually identical, but one is single and the other is married. The married customers generally have a higher lifetime value by a difference of about 17. So once again, I'm not going too mathy, and I think people could understand that if we're kind of saying 2 observations were otherwise identical, but different. One is the reference, one is the indicator. You don't want to say things like reference. You don't want to say things like indicator. You're just saying we're comparing our married versus single customers, and we generally see more for the more. But you got to be careful, because the reason we do it this way is we try to have you learn it at this level to where you're very exact, because we don't want you to oversell things. You don't want to say things like, if we market to married people, we will make more money. No. And it's kind of odd to say otherwise identical, but we generally see a trend in the data. We generally see a trend where married customers have a higher lifetime value. And you might say, well, didn't you look at the indicator for single? Well, yeah, but I mean, if the it's comparing it to married. And that's why if we see right here, this has a negative coefficient that's compared to the reference level. And that's where the knowledge comes in of reference and indicators to say, well, this is the difference we see between married and single people. And this is the difference between the male and female coefficients right here. So kind of answers another one. But yeah, good stuff right here. I like it. We might end right here. A lot of other questions. We will be back. I'm going to take a quick break right here before class. But amazing work, everybody. We'll be doing some more Stat 201. I think we've got more Stat 201 questions. But thank you, everybody. We're back this week. We're doing some full office hours. I'm going to go get ready for class. Huge thank you to everybody. We'll be back doing some more 201. We got a lot of 201 questions done at the start. I think we've got, what are the questions? We'll do the rest of the questions. We got everyone. See you in a little bit right here. You're welcome, Michaela. Great work. We'll do some more 74, 74 if you want later today. See you then. A little bit here. Bye for now. 2:45 your time. See you then. Bye.